Woo! What a morning. As much as you need to be mentally ready for your math lesson and your day, you need to be equally or even more physically fit because your physical fitness translates into your mental fitness. I just came back from a beautiful morning of tennis. I've been up since 5 o'clock and I feel ready. I feel energized for the day. I feel energized for our math lesson today. Welcome to Math with the Real Floater. Let's go! Welcome once again to another in the series of Math with the Real Floater. Welcome back to all our loyal subscribers. And for person who are taking notes, kudos to you. You'll see the benefit in short order. We've done the addition of fractions. And as far as I know, addition and subtraction pretty much falls in the same line. Alright? So today, let's get into the multiplication of fractions. Alright, we have 2/3 times 4/5. This is the same thing as 2 times 4 over 3 times 5. Okay, which is equals to 2 times 4 is 8 over 3 times 5 is 15. So that's our answer. So 2/3 multiplied by 4/5 is the same thing as us multiplying the numerators, okay, over the 3 times 5, which are the denominators. So it's a multiplication of the numerators over the denominators. All right, good. I hope you're catching on. I hope you're keeping up with us. If not, pause the video or you can go back and rewatch. All right, 2 nines times 1 and 2 over 3. Okay, this is equal to, we have 2 nines multiplied by, this is what we call a mixed number. We now must convert this to an improper fraction before we can do our multiplication, okay? So to convert, 3 times 1 is 3, plus 2 equals to 5. So we have 5 over 3. This is equal to 2 times 5 over 9 times 3, which is equals to 2 times 5 is 10 over 27. I hope you're keeping up with me, okay? So it's a multiplication of our numerators over the multiplication of our denominators. Come on guys, if you love this content, please subscribe. Turn that notification bell on. Like and share. This is Math with the Real Floater. 3 over 4 multiplied by 2 over 5, which is equals to 3 times 2 over 4 times 5, which is equals to 3 times 2 is 6 over 5 times 4 is 20. Now if we look at this, we can break this down even further because we do have a number that can go into both the numerator and the denominator without leaving a remainder. And that number is 2. So 2 into 6 goes 3 times. 2 into 20 goes 10 times. So whatever you do to the numerator, you also do to the denominator. So the fraction remains the same. So 3/10 is the same thing as 6 over 20, and we call those equivalent fractions. Now, I'm going to show you a different way that you could have gotten this same answer, 3 over 10. So let's just write this down up here, okay? That's the answer we got. Let me show you a different way in which you could have come to the same answer. Okay, when you see fractions being multiplied, what you can do is this. First thing you ask yourselves, am I seeing anything in the numerator that can go into the denominator without leaving a remainder? Or can I see anything in the numerator that I can find a factor that can go into numerator and denominator without leaving a remainder? In this case, yes, we can. We have 2 and 4, they are both even numbers. So we can find a number that can go into each of them without leaving a remainder, and that factor is 2. So we can say we have 3 over 4 times 2 over 5. So 2 into 2 goes 1 time. 2 into 4 goes 2 times. Okay? So we end up with 3 times 1, 1 over 2 times 5, which we get 3 over 10. Same thing as what we got up there. So as I said, if you can find a number that can go into numerator and denominator without leaving a remainder, you can go ahead and do that. Notice I did not say numerator and numerator or denominator and denominator, right? You can only divide the numerator and the denominator by a similar number for it to be that equivalent fraction. Let's say we have 14 over 27 times 3 over 2. Okay, if we look, 3 can go into 27, right? Okay, and 2 can also go into 14. So let's just go ahead and do it right now. 3 into 3, 1 time. 3 into 27 goes 9. 2 into 2 goes 1 times. 2 into 14 goes 7 times. So this is equal to 7 times 1 over 9 times 1, which is equals to 7 over 9. Pretty easy, huh? Nothing to it. Okay, if you keep on working with math with the real floater, you'll become a maths genie in no time. Let's work with this one. 16 over 19 times 3 over 10. Right now, we have 2 even numbers, 10 and 16. We have 2 odd numbers. Can 3 go into 19 and don't leave a remainder? No. However, we have 2 even numbers, 10 and 16. Now, 10 cannot go into 16 without leaving a remainder. However, we can find a factor that can go into both 10 and 16 and don't leave a remainder. And that factor is 2. Please revise highest common factor. 2 into 10 goes 5 times. 2 into 16 goes 8 times. Okay? So now 8 times 3 over 19 times 5, which is equals to 8 times 3 is 24 over, what's 5 times 19? We can come here real quick, times 5. 5 times 9 is 45. 4. 5 ones 5 and 4, 9. 95. Down here, 95. That's our answer. Pretty easy, yeah, nothing to it. Let's do another multiplication. 1 and 5/8 multiplied by 7 over 26. Okay? First we convert this into an improper fraction. 8 ones 8 plus 5 equals to 13 over 8 multiplied by 7 over 26. This is our lucky day because 13 can go into 26 2 times. 7 and 8 can't. 13 into 13 goes 1 times. 13 into 26 goes 2 times. So this is equals to 1 times 7 over 8 times 2, which is equals to 7 over 16. If we ever see 3/4 of 16, all this is saying to us is 3/4 times 16, okay? Which is the same thing as 3/4 times 16 over 1, which is the same thing as, of course, first we ask ourselves, is there a number that can go into numerator and denominator and don't leave a remainder? In this case, sure, that's 4. 4 into 4, 1. 4 into 16 goes 4. So we have 3 times 4 over 1 times 1. So we get 12. Thanks for joining us. See you next class.